Okay, I'm going to demonstrate, probably don't know this, what an operating system is. So very easy. Operating system is this. Over here's your hardware. That's your devices. It's hardware is anything that's not software and is basically the stuff you can touch is your hardware. The OS is software, and applications sit here, and you are here, and you use the applications. Applications use the OS uses the hardware, and that's how things pass. They pass this way, then they go back that way, and you see the display, the output. Actually, you see the output come directly out of the hardware, the display. But that's the progress of how things work. And your operating system, if you're on a PC, would be Windows. If you're on Mac, it's the Mac OS. If you're on a cell phone, it's Android, or it's iOS, or it's iOS. iOS is for the iPads. Or if you're if you're unlucky enough to have a Microsoft-based cell phone, then it's basically a washed-down version of Windows. And Android here is Linux. Linux is another operating system. And there's a whole slew of other operating systems, like you've got FreeBSD. Forget it. FreeBSD, which stands for Berkeley. School something or other, and it's Berkeley, and Berkeley made it. And since Berkeley is a public school, the government used BSD Unix, which is what this is. It's an official version of Unix. Means it's better than Linux. It's closer to what inspired Linux, which is Unix. BSD Unix was there were two or three. There's actually three versions of Unix in the universe. There's no, it's two. It's sysv. That's AT&T. And then there's one called BSD, and then there's BSD, which is not sysv. It's BSDs, and BSD Unix is what the government uses, and since they determined they use it so much, they shouldn't have to pay for it. So they forced BSD to open up, make one version of BSD Unix free, and that's the one that runs on the Intel processors. And so that's what my brother uses. He prefers this to Linux. And then you probably heard, can I erase all the strokes? Yeah. You probably have heard of, let's see, well, there's BIOS. I'm talking BIOS, which is dead. That was kind of a multitasking operating system back in the PC. There was one that Microsoft made. I think this is right. It's Minix. That was Microsoft's version of Unix. And then there's Iris, which is the SGI version of Unix. And or it was actually called IRIX. And then there's one called what's IBM's version of Unix is dang it. I forgot it. It'll hit me in the mind eventually. Not very interesting. Then on MIPS processors, it was called Ultrix. And then on Sun workstations, Sun was created Java. It was Solaris. And they also had Sun Unix. Sun Unix, I think, was another one. Solaris is kind of a different flavor of Unix, I think. iOS was inspired by Unix, but it's not Unix. And it was inspired by the Next operating system, which is what became iOS later. And it used to be that Macs ran on an older operating system that was the Macintosh operating system, and then it switched over to Next when they brought Steve Jobs back, and he named it iOS, and the Xcode, which is the development environment, was from the Next. Xcode is basically the interface, or the IDE that is used. That's an interface development environment. And it's also the integrated development environment. That's what it stands for, not interface development environment. This is an IDE is what a programmer uses in order to write programs. So Xcode is this comes free with the Mac operating system. So if you get a Mac, you should be able to get Xcode for free. And it was also part of the Next operating system. Whenever it was Next, it was the Next development environment. And this was the software, actually, the stuff that came from Next was the software that created the game engine for the first, one of the first 3D games, Doom. And it was programmed on the Next, and then it was ported to the PC and married with assembly, which is low-level programming. And so that's what became the Doom engine. Is basically an entire, it was like artificial intelligence, or game engine, and then it was ported to PC and then married with assembly language, which is basically machine code. It's the difference is assembly is what humans can read, and machine code is what the computers read, and nobody ever programs in machine code unless they're masochistic, and they just like to torture themselves. So, and on Android, you will have an Android IDE type environment. If you're on Java, Java has its own IDE, and the Java and C++ and C# and not C, but C++, C#, Java, all these are called object-oriented languages. They usually call them object-oriented programming software, OOPS. So this is object-oriented languages, and or OO, object-oriented, and these were inspired by a grand one called Smalltalk. And Smalltalk is both an operating system and it is a language. And some people say, how is that possible? Well, in the same a Java is basically, it would be like Java married to your hardware. And in the old days when you had Commodore 64s, like a C64, the first computers, the home computers, the language talked directly to the hardware. It had a minimal operating system, but the language, you wrote your software in this, and you would run programs, and those would be basically your operating system and your application all in one. And that was good for back then, but then when you in order to simplify things as your hardware got more complex, you would not be able to do this for very long, or this would have to become more complex to use that complex hardware. The interest was to put your language here, and then have your OS, and then your hardware. And that's to, and your language would be what you wrote your apps in. And then people would use the apps would use the operating system would use the hardware. Now you're probably thinking, when I go to try to load a program, it's going to wait, and then it's going to give me the program. When you open up an app, it's going to talk to the OS, and the OS is going to go to the hardware to get the app, and it is actually going to wait a while, and what it's doing is it's loading from hard disk the app, which is putting it into memory, and then when it's ready to execute, it executes the app talks to the OS, and the OS talks to the hardware to open up the display, and then your mouse interfaces with the hardware, which permits you to draw onto the display or move the mouse around on the display, and then you look at the display and you can determine that your app is working and all the icons are in the right place. But what I was going to say is that the operating system doesn't make everything stop in order just to load up from the hardware. What it does is it sends what's called an interrupt to the hardware to tell it to go and call something in the operating system once it's fully loaded the app into memory. And when it does, the hardware will send an interrupt to the operating system, which will trigger a driver. And I think, is that right? And the driver, actually, it sends it to the OS. The OS doesn't know how to handle it. The driver handles it. The OS talks to the driver, and then the OS is able to go to load in the application, which runs inside of its memory, and then you're able to use the application. So, that's a lot of what goes on whenever you use your computer or you use your cell phone. If it's your cell phone, your touch screen is your interface, and the Android is your OS, and the OS handles the touch information, but in order to handle that, the touch is actually in the hardware, and the hardware invokes Android, and Android puts the stuff on the display, which is actually hardware. So it's actually the Android's talking over here, and the hardware then puts up something on your display and you interact with that. So that's kind of how it works inside of a cell phone. The reason why I'm talking quiet is because people are sleeping, and as you can see, it's 1:54 a.m. It's a Sunday. I just felt the need to do this. Okay. On top of that, what is, well, we got Windows. I told you about Windows. How is it on Linux? You probably heard you can do this. How is it on Linux? You can run Windows software without Windows. And it's what it's called. It's called Wine. In the spirit of every GPL, GNU public license, GNU is like wine. GNU means GNU, not Unix. GNU. And so that makes it's called a recursive acronym. And WINE stands for Wine is not an emulator. And you're probably wondering what an emulator is. So this is what an emulator is. An emulator is it's basically an emulator would actually, if you had the hardware and all the stuff that made up a PC, you would need an emulator if you were safe to run it on a Mac, and then you would use that emulator, or you could use a sandbox environment to put Windows in, and then the emulator would talk to the OS, and then the OS would talk to the hardware. And so an emulator assumes that you got Windows and you've got the, like VirtualBox or hypervisor, that is the sandbox environment that then interacts with the operating system and interacts with the hardware. In here, Windows is also an OS, but that OS is working on simulated hardware, which is what the emulator does. And then your apps sit on that, and then you interact with that. And that's hypervisor. That's an emulator. Hypervisor is actually difference between an emulator and a hypervisor. Is a hypervisor doesn't translate system calls. It doesn't translate. It doesn't translate or it's the emulator implements the basic operating system or BIOS of and the working environment of a specific kind of computer. So your emulator, in this case, if you were running Macintosh software on a PC, then it would be a Mac emulator, and it would run on a PC, and then you'd still need your Mac OS up here that would talk to the emulator. A hypervisor doesn't have an emulator in it. What it does is it basically creates a sandbox, which is just what a sandbox usually is it is a what the hypervisor is it is a what do you call it? It's like a partition. It's not a hard drive partition, but it is a memory partition, and it's a memory partition that also is interacts with a operating system partitioned part of the operating system. It's basically the operating system kind of puts a shell around it, and it's called a sandbox. And you run, you load in your operating system into the hypervisor, and the hypervisor interacts with the operating system. And what the hypervisor does is it basically filters. It filters what calls it can make to the operating system and certain calls it can't make. And actually this is the BIOS. So this is the hypervisor is like a layer that goes in between the basic operating system and your operating system, which would run inside of here. And so the reason for that is that so the hypervisor interacts with the basic operating system, BIOS, and that interacts with hardware. And this right here, usually whenever you're running Windows, what you're really running is you're running Windows and BIOS. Windows talks to BIOS and BIOS talks to hardware. And hypervisor is just basically a middleman between the Windows environment and BIOS. And it sandboxes this so that you can actually run another hypervisor or another session with say a Mac, an Intel-based Mac operating system, and have it also talking to the BIOS, which is talking to hardware. And you can have these two operating systems coexist on the same processor, on the same hardware. And what cloud computing is. What cloud computing is it's basically that hypervisor, and it loads in an image, and the image contains in it your operating system and your software. And this constitutes a server, what's called a server. And when you interact with any app on the internet, what you're really interacting with is a OS plus app captured in an image, and the image is executed on a hypervisor which talks to the hardware. And this part is protected. That's protected from the operating system. Actually, OS is over here. It's in the image and with the app. And so the way to think about it is that when you've got a lot of users coming in to a server, like a web server, the web server is actually going to spawn off images of the server environment that needs to interact with these calls, and then that will spawn off other images on other hypervisors on other hardware. And what it basically does is it lets you load balance all the calls. So the more calls come in, the more images are spawned off, and those images are spawned off on individual computers. So you got a computer, and so the image on that, and then you have another computer, and then there's an image on that. And this is a working the environment, and when the image gets executed, it's as if it's just a completely installed environment, and it's I hope this I put this mic, yeah. Oh, actually, I think it's taken that. I know the recording's going in there, but the image is kind of the installed. What is it? Is a capture of the working environment of the operating system and the apps and everything that you installed into your operating system environment, then captured in time, and then it's frozen, and when it's needed, it's put into a hypervisor and executed as if it has been run on the same day it got the software installed, and the calls go in and talk to the software inside of that that image produced when it needed to run another server, and then the users interact with that server. And when they do web calls, and when this load goes down, it kills off all those servers, and that's cloud computing. That's what it means to do cloud computing. And as with everything that happens in the computer world, or in the software, in the tech industry, there is marketing people that will hijack the term and use it to describe something else that people don't understand. And really, the way they describe it is not what I just told you, but it's really just recoining what exactly a service on the web is, or a web server. When you go and use an app, the app will talk to the web service, and then that works with your documents and whatever that interacts with your documents. The apps work with that, and you're using this consists of this server, and you would call that your cloud. They call that a cloud, and the idea is that to them, what the cloud really means is that this is the internet plus your apps plus web servers plus storage, and no matter where you go, you are going to connect with that, and your apps and all your data are contained there, and they call that the cloud. And I can see how that would kind of be the same idea, that your environment that you interact with over the web is really just an image. It's actually the data on a drive interacting with a hypervisor, an image running on a hypervisor, and it will And that whole thing will be, it's not only your applications are working with that, but everybody's application is working with that. And that's running on hardware, and it increases the number of applications running on the number of PCs as the load increases. That's more people come in and want to use applications that sit on the on these servers. And so if you use any kind of app, most apps are just JavaScript and some graphical interface stuff. So it's like JavaScript, which is not Java, by the way. That was also another hijacked term marketing people used for JavaScript in order to get people to use the language. It was really called, I think it was called ActionScript or something, and had some other name, and then they named it JavaScript to try to hijack the success that Java was having. And they are not related. So anyhow, so when you use an app, they're called Web 2.0. And what Web 2.0 is, it's asynchronous JavaScript, or called Ajax, and asynchronous JavaScript and XML. And XML is really just a data format. It's a architecture and independent. It's agnostic file format, and XML is really just an overly loaded name. It's a loaded name, which really just means data encapsulation inside of a text file. So it's encapsulation. It just takes, and it encapsulates it's kind of like those Russian dolls. That's XML. Is like Russian dolls that you put your information in a little Russian doll, and then you put that Russian doll inside of another Russian doll that contains, maybe has little notes inside of it. So you write some notes and you put it in a Russian doll, and then you know which notes are not related, or which notes have to do with which Russian dolls. And then that encapsulating is the same idea, and you would put your messages in with the doll. And so if you could imagine that you had your Russian doll, let me see, this is the Russian doll, and they have their, and face, and then hands. So that's your Russian doll, and it opens up like a capsule, and then it will contain another smaller Russian doll. And let's see, I could probably bring in a picture, but I would have to load it off of the internet, and you can just look a Russian doll up on Google Image, and you can see what I'm talking about. And so if you can imagine that you had a capsule, like a drug capsule, you put in their information, and then inside of that there was another capsule, and it had information in that. That isn't related to this. That is your information in one capsule is in there, and then that capsule is put inside of here, and it has information, but it's related. It's not in this capsule, it's in that capsule. And then that's encapsulation. That's what they mean by encapsulation. And all XML does is it encapsulates information using these things called tags. Here, that would be the tag name. And then it has an ending tag. And the tag is you would put a name in there, and that name defines the type of information that is contained in here, and data is just text, or it's encoded text, and just as with the Russian doll, you would have, say, you would have a doll 1 here. And you'd end doll 1 here. You would have doll 2 here. 2. And then, and then you would have some data here. And you'd also have some data. You could have some data here. You'd have data down here. But that's a capsule, and this is a bigger capsule, and that's how XML works. And it's really just dumbed down. HTML, hypertext markup language, is just a flavor of XML. And this is web-oriented. And this is implementation agnostic. And so it applies to all sorts of stuff, and so it doesn't rely on the web. And usually, the reason why we use XML is to pass information into JavaScript. That will it will encode information. It'll stick it in an XML format, and then it will send that over to the server, and the server will call up the app that will say it's a PHP app, which is a language. And then that PHP app will interact with, will re-encode information into XML, and then it will send it to, what was that? That's JavaScript. I think that's Java. So it that will interact with Java on, and this is in the client, which is the web browser. So you got web browser here. The web browser. Let me do this over again. You interact with an interface, GUI, that is talking to it's talking to JavaScript. That is then talking to the operating system, or talking to the web browser. That is running on your Windows or your Android, whatever. And this comprises of the front end, or client front end. This is your computer, and that's called the client. So this is the client, and then the server is it's a client, but it's a client that runs on a PC in the cloud, and then your client is the presentation. The server is where the actual business is done, and that's called Web 2.0. Because it uses JavaScript and XML together to send packages to the server. The server unravels the packages, acts on them, then sends XML back, and the JavaScript decrypts it, and it sends it to your screen, and you think that you're running an application on the server, but what you're actually doing is that you've got your client, and the client is the front end, it's the GUI, and anytime you interact with the GUI, it sends calls back to the server app. And that's the app that you're actually interacting with. And when something happens with the app, it'll send back a display call or something, which will use the JavaScript and whatnot to throw the stuff up on the screen. And so that's how web apps work, and it's called Web 2.0 in marketing terms. And what it really is it's just Ajax. That's all it is. JavaScript married with XML. So that's another kind of operating environment. So I've covered a lot of operating environments. This video going to get too long, but okay. And I didn't really talk about wine, which is what I was going to talk about. I veered off to talk about operating systems and hypervisors and cloud computing, all sorts of stuff. What wine does is it's not an emulator. It's not a hypervisor. It's not any of that sort of stuff. What it does is and I'm going to turn wine translates. It's a translator. For it's an implementation. It's called a thin client. And JavaScript and XML is a thin client. Wine is a thin client. And so your apps, your Windows apps, talk to the thin client, which is Wine, and the thin client translates those calls into Linux calls. And anything that's not implemented in Linux, as things tend to, the operations that Windows perform are usually not that much different from what Linux performs. And this thing just has to translate the name of the functions into something that Linux works. And that's what Wine does, is it just translates. It doesn't emulate anything. It just basically translates Windows API calls. And so an API is an application's programming interface. So the API would be that would be the OS. Usually it's the OS and the API running on the PC. And when you have apps, your apps use the API, which then uses the underlying operating system, and it's on the PC. And this would be Linux and Wine. And so your Windows apps are over here, and this does not require Windows. And so it doesn't require Windows. It can run on Linux. So again, this is how it works. Windows apps, Win apps, talk to Wine, and Wine talks to Linux, which is your OS, and Linux talks to BIOS, and BIOS talks to hardware. And the hardware includes your display, which shows you happened, and you interact with your WinApp, which then makes calls to Wine, and Wine translates those to Linux calls, and then Linux works with the BIOS, and which causes this whole cycle of interaction. And so your games would be here. Your Windows games would be here, up here. Game. And it would be interacting with Wine, and then Wine would be interacting with Linux. And Wine there's no reason to run Windows, because this together simulates Windows. It simulates the Windows environment by supporting the OS. Linux has all the basic stuff that Windows has in it. The only thing that's different is the API, and your WinApps can only run on Linux if it's got something to translate for it. Otherwise, it will need Windows. And that's the reason why Wine doesn't require Windows, and it's not illegal to implement an API. So it's therefore not illegal to run Windows programs on a Linux computer, because it's not illegal because you don't require Windows. Windows is usually just the operating system. But with Wine, it implements the Windows API, which is what Windows apps, your games use. They use Windows, and all Wine does is it basically says ditto, but it's Wine plus Linux. And Linux is just another operating system, and Windows and Linux do pretty much the same things. They both talk to the hardware. And this simulates, not like an emulator, but it implements, you could say it implements the Windows operating system environment. And the game then interacts with that, and you don't require Windows. And because you're not using Windows, you're not copying it illegally. There's nothing illegal about it. This is just implementing a superset of or it's a subset of the Windows operating system. And the strive is to make Wine look more and more like Windows, so that your game developers don't have to develop on Windows anymore, and they can develop on Linux Wine environment and eventually get rid of all the Windows calls and just run on Linux directly. It gives them a transition. And this is the thing that Microsoft hates. They have no recourse or nothing, but Microsoft hates this like the Antichrist, because it means the death of Windows. And it's a win for game developers, because then they can get off the Windows platform and they stop having to pay money. They stop having to pay money to Microsoft, and we can basically get rid of Windows, which is a sucky operating system, has been from day one, and it shouldn't even exist. And most of your nerds are over here, and your biz heads are over here. And they're the guys that push the Windows operating system. And most nerds don't want to use Windows, they want to use Linux. That's the reason why all your server applications, your Android and everybody else in the universe uses Linux, and Windows the only reason why Windows is different is because it makes the money to keep it different. So it makes the money. This is the reason why Microsoft makes money, is by keeping this different, not better, just different from a Linux environment, which is free. Linux is free. And that's the reason why it's so attractive. Linux is so attractive, is it basically does Windows, and it's better, and it's very simple, and Microsoft could always make better software, but it would never be free. And so this is usually what we, Android is Linux, and pretty much every like little piece of electronics that you use, even microwave ovens, will run Linux. And Microsoft Windows is too lethargic and big. It's lethargic and big to be used really for embedded systems. So people tend to go for with Linux. It makes them no sense to use Windows because it costs money to use Windows. So they would prefer to use Linux. And your Mars rover uses Linux. And pretty much everybody. And the reason why they use Linux, and the other reason why they use Linux, is because with Linux, since it's free and the operating system is free, you can manipulate it. You can size it down, you can water it down, only use the stuff you need to use. And so it doesn't have to be this Windows OS. It doesn't have to be an awful Windows OS with apps. And this is just large. It's large. This can be simplified. You just get a subset of the features that you need, and you stick with that, and then you can quickly put that on hardware. And hardware manufacturers tend to prefer Linux, implementing on Linux before they ever throw it on Windows. And even there will be applications that work in this way, work in this manner, and they'll throw it on Windows, and but it won't be. It will be operating system agnostic. Aside from Linux, it will not prefer. Oh, I just dropped out there for a while, but I'm going to end this video in 8 minutes. But anyhow, the advantage with Linux is it's free. It can be manipulated, it can be watered down, it can be customized. Like a van is customized by a crew. They can make it look cool. They can make this look cool and give it lots of features. And then they can make it really small, and they can put it on specialized hardware. And then this all becomes a product. You buy the product, you use this. You're not using Windows. You're not using Windows running on a watered down PC like a cell phone, which is what those Windows cell phones are. And this is free, or basically free, and this costs money. It's cost money for the developers and for the user. When you're buying the product, you're actually buying Windows, and if you were to be a developer, if you're to put it on another cell phone, you would pay Microsoft money. But with this, it's free, and so they don't really have any interest in using Windows anymore. And basically, they will say that Linux won the server. So everything that's on it won the server war, and nobody uses Windows much for servers. They don't. And so the future is not Windows. Windows is it's on the out. It's just that Microsoft is trying to see how much they can keep you on this. They want to keep you here, whereas your Android phones and everything over here in iOS is like Linux. Everybody else is using this, and people don't use PCs anymore. They use cell phones. And so Microsoft is forced to take a back seat, and the windows get smaller and smaller until we don't, in the future, 100 years down or 50 years, maybe even 20 years, nobody will ever use Windows again, and it will be dead. And if you have to use a Windows app, it'll probably be running on Wine inside of Linux, possibly on your cell phone. Sometime in the future, you would be able to use your cell phone where your PC was, and Wine would run those programs, or Wine and Linux would run those programs, basically without Windows. And Microsoft wouldn't get a dime of it. So there you go. That's kind of an explanation of Wine. And right now, Valve, which is the guys who created Half-Life, they created Half-Life 2 and Portal and Team Fortress 2, and they created all those programs. We call this the Orange Box, because that's the collection of all those games. That will run on the Orange Box, will run on Wine pretty much flawlessly. And that was like the first thing you could run on Linux. And I played Half-Life 2 like just many, many times. And now what Valve is doing is they're developing Wine. They're augmenting it, and they're putting it back into the free. They're putting it into the free realm. The changes they make to Wine go there, but then this is their customized product that is included in Steam. So on Linux, Steam is really just Wine and Linux. And so that's Steam over there. And Steam here uses Windows. And Steam is basically your app store. And it's also your environment for the game. You kickstart the game. In the case of Wine, it puts the applications, it installs them through Wine on Linux, and then you run the apps within this environment here without using Windows. So you're not using that environment, you're using this environment. And Valve, the people that run Steam, they are developing that so that they can someday get rid of Windows altogether. And then they can make this a product, and that could be like a PlayStation. It could be like a PlayStation or an Xbox. But it would be the Valve game environment, and it'd basically get rid of Xbox and Windows. It would be the Windows API, so it would basically get everybody in. And so what Steam is, if from the business world perspective, Steam is basically a Walmart. And that here it is, it's called a walled garden. It's a walled garden where all the games run, and they run on cheap software, Linux. They can run on Linux and if it's Windows, it's in Windows, but you then buy your apps from here, and it installs the games on whatever hardware, and it's a walled garden, which is what Walmart is. And all the products that are sold at Walmart, they're kind of in the walls of Walmart. That's the reason why it's called walled because of Sam Walton. But it could also be called a walled garden. It's a sandbox environment for where all your products are, and so this up here is the same thing. It's that's what Steam is, and all Steam does is it installs the games that will run on Windows and on Linux. It usually Steam used to run on Wine, and then but now it's going to get married to Wine, and it's going to keep itself separate, as everything in open source is required to be separate from every other application, so that they can be. This is something that occurs in Linux. It doesn't occur in Windows. Is that every software library, which is all your functions, every software library is separate, and they use each other, but they can't encapsulate the other, and that's so that the developers can develop that are interested in that one thing, and the developers that are interested in this one thing don't have to talk. These guys don't have to talk, and they will use each other, use their stuff, which will work on the OS. And when updates are made, they made to the libraries individually, and the entire operating system doesn't have to update. Just that software, and that software uses each other, and as a result, you don't have this problem called fragmentation that you have in Windows. Windows has fragmentation, and what that's mean is that in Windows, every game has its own collection of libraries, and some of those libraries include stuff. Say, some of those that are in another game that has its package with library and stuff, same stuff. So the same stuff that's here is pretty much the same stuff there, and that all runs on Windows. And the purpose for that is so that an older version of the stuff, which would be older libraries for Windows, are included with one game, and with another game they have a separate set of libraries that basically do the same thing but in a different way. And so say this one was running on 5.0 and this one was running with 4.0 of the libraries that Microsoft created, and then Microsoft changes it every year, and so they will still run 4.0 versions of games, and this is 5.0. The 4 and the 5 are just fictitious. The idea is that this comprises a kind of an environment, that comprises an environment, and Windows will run both, but the libraries inside are specific to that release of the Windows programming environment, and so you have a lot of those inside of Windows, and they all are using this same library in different versions. And if there's a security hole in that library, then they all have to be updated. Whereas in Linux, your games use Wine, and Wine uses other libraries, and these libraries can't be distributed with Wine. So and Wine might get updated when these libraries get updated, but the idea is that if there's a security hole in a library, you just update the library, and that's that. You don't have to update in every single game, and unless there is libraries up here that need to be changed, then you have to update them. But the idea is that your security is like going to be down here if there is anything in Linux and in the libraries that Wine uses, and the way that Linux is arranged, there's as with those games, there's no replication of the same libraries with every game. And the reason why that occurs is because of the commercialization of software. In freeware, it makes absolutely no sense to do that, because the libraries are not licensed. So the libraries are distributed for free with the operating system. So they exist with Linux, and they're not in the game. They're not in your applications. Your apps don't contain. They don't contain the libraries that they use. They're over here. And as a result, security holes, Linux has less security holes because it's not having to go through and change all the libraries that exist in every single game that's running on Windows, or every single app that's running on Windows. And that makes this more secure and this less secure. And it's called fragmentation because it is putting a fragment here and a fragment there, and then you have to update all those fragments, whereas inside of Linux, your library is in Linux, and it only has to be updated once. Every library that has a security hole in it just has to be updated once. It doesn't have to update libraries in every single package install, and that's what fragmentation is. It's called there's different kinds of fragmentation. There's memory fragmentation, and that is when you inside of your computer, it's called memory fragmentation. This is when you've got like little programs. Say you had programs in your computer, and the programs have their installed stuff, but then they allotted a certain amount of memory. This was before page memory. They would create kind of an allocation of memory that the program would run in, and then there would be some memory that didn't get used, and so this is called fragmentation. Just like fragmentation on a disk. When you got a disk and you got little memory pockets in here that can't be used because they're owned by certain data files, and then as with Windows, you install all those programs and it uses up your hard drive. You have to buy another hard drive. Linux tends to be very efficient on hard disk use because there's no program fragmentation, so therefore no replicated data. And as a result of not having replicated data, it tends to be tight. And the reason why that is the case is because Linux is free, and it makes no sense to pack different libraries with every program, so it makes it tight. Whereas with Windows, because it's commercial software and it has licenses with every single game, and the libraries have licenses, they can't be that can't be distributed with different programs, so it can't be put in the operating system. If there's security holes in those libraries, they have to be updated individually, and it takes a long period of time. But in Linux, the strive is to not have any proprietary libraries, no special licenses, because it's not commercial. And so all your libraries are inside individually and not encapsulated with each other, so that you don't have any fragmentation with the Linux OS. And this is also how it's in Linux is also Android. And so the security holes, this Linux is more secure, whereas commercial is less secure. And this is called open source sometimes, but it doesn't mean the same thing. And this is called closed source, because only the people that created the programs can the commercial programs, they're the only guys that can look at the source code and make modifications. In the Linux world, everything can be modified by the users and customized. And here there's very little customization. And so the interest of the world now is that commercial software kind of died in the server market, in the operating system market, because it makes absolutely no sense to put commercial software in the operating system. This is the socialization. This is kind of socialization, like you do with the government, is that all the basic services are provided with the government and not in the commercial marketplace. And the reason for that is so that not every company is implementing all the products, and everybody is making the same products, but they're making them different because they're trying to make money. And this creates a lot of fragmentation and a lot of crippleware, and creates legacy software. And it, though the programs can still run, this stuff becomes legacy. Whereas in this is always updated and made better, and it makes no sense to put all your libraries into your application that the applications use that are similar. It's best to put those into the operating system, and it's best that this is free and that your applications are commercial, and that they only contain stuff that separates them from other applications. And so that's the future. The future is free OS. Free OS. Future, this is the future. Is a free OS running commercial applications. So this is like your apps. And even Oculus, the Oculus store, is just using Android. It's the reason why you can sideload Android apps onto an Oculus VR headset. And it's because it's really just a free OS running its commercial software and hardware, and the apps you pay for, and all the apps use the Oculus stuff, but the apps don't contain special libraries that would be implemented in the operating system. And so this stuff is simplified, made simple for the developers, and the complexity is wrapped up in the environment, and they can still make money because this is in a sandbox, and none of the other apps can mess with each other. They can talk to each other, but they can't mess with each other. And they have very little fragmentation, and the apps are very small because all your libraries are over here in the operating system. And because you don't have replications of the same libraries across the applications, these are smaller. They're more secure. Smaller also means more secure. And they can't be manipulated by hackers, because the hackers would have to go through the App Store and stuff to change the programs. And they would have to hack this, but they couldn't literally get access to that unless they went through the App Store. So that's the future. The future is to do that, and you cut down your memory, you make things more secure, and you install apps using app stores in a freeware operating system, and your apps become cheaper to develop. They don't involve as much complexity, and that's the reason why they tend to be cheaper. And there's really no reason why Oculus games have to cost 5 times. There is no reason for a Oculus game for a Quest to cost more than they do for the Go 5 times more. It really would make more sense to make it 2 or 3 times. But they're doing 5 times because it's a walled garden and people are using the Quest. They're using the Quest and they're not using a Go. And the Go is slower. And so because you spent more money on this other headset, they're trying to make this more profitable for Oculus and for the Quest, for the developers. And that will also attract a lot of professional game companies, which will create better applications. That's the reason why they're trying to kill off the Go, is because that was really just a proof of concept. Proof of concept. It's a pilot. It's them saying, is there a market for this? And when they determine a market was made for this, they'll stick their, they will go out on a limb to create this, and then they'll provide this. And if people bite and they buy this, then they get rid of that, and this becomes the future of that VR environment. However, also what's happening is they're making chips now that basically do what Oculus does on Android. And these chips are going to permit lots and lots of people to implement VR environments. It's going to permit them to create VR environments on cell phones and stuff like that, or on basically cell phone operating systems on the on specialized headsets. And each one of these guys will have their own app store, or they'll have a Google app store, and they'll be using Google App Store, and you'll be getting your games from Google Apps, and you can use all these VR headsets, and they will be running just as well as Oculus, because what Oculus is trying to do is they're trying to do what Microsoft was doing with Windows, but they're using Android because Android is Linux, so they get the benefits of Linux and less security holes, but they're trying to